Hello, I'm Don Walkner, president of eData Law Group, and this is one of a continuing series of podcasts on the forensic analysis that the forensic side of eData Law Group performs basically through the law firm, my law firm, the Walkner Law Firm. The forensic analysis is designed to investigate, identify, and confront those people that are causing a problem, or those identify the communications and people and transactions of interest as we try to figure out what has happened in pursuit of some type of legal or confrontational objective, either firing somebody, defending somebody, getting ready for a civil suit, or even sometimes doing due diligence alongside a criminal investigation. The other side of our company, which will be handled in different podcasts, is the Digital Safety Group. DSG provides those services necessary to insulate, manage, and report to parents, teenagers, etc., the ways in which their devices are being used. This is a protection series of services. This is a confrontational, more aggressive series. This is the iron fist in the velvet glove. So let's take a look at what we're going to be talking about in this podcast. This podcast is how do individual devices work? How should we think about them? Other podcasts, we talked about how to think about devices in general, the environment in which you live. In this podcast, we're going to kind of drill in. And we're going to basically say, look, the environment is comprised of things like computers, cell phones, cell towers, etc. It's comprised of a lot of digital devices. Some computers are embedded in cars, some in aircraft. Cell phones have got cell phone devices have got information inside of them, and they send information across towers. Towers have got information on and on and on. Do we have to really think about every device differently? And the answer to that is no. In the same way that we can generally think about humans as being basically people that have memory, that have language, they have mobility. We can generally build skill sets to interrogate humans. We might need to get somebody to interpret a language for us if need be, but we are not blown away and rendered ineffective when someone says, well, my goodness, there's 300,000 people in this company. How could we possibly investigate anything? Well, of course, not all 300,000 people have anything to say to us. Number two, once we identify the people of interest, we will find ways to communicate with them. And the same is true with digital devices. Once we've identified the digital device, we'll find ways to communicate with them. But in identifying the digital devices, not only do we need a general idea of what the environment's like, but I find it very helpful to have some kind of idea of what the heck are we talking about when we say that a device might be a great witness. Is it because the device writes everything down? Well, not always. Is it what's in the device, what's not in the device? How can I think of this? And in a sense, how can I explain my observation or my suggestion to somebody who says, I got an idea. Why don't we look at Bob's computer? Well, Bob left a year ago. Well, let's still look at his computer. Well, why? He's left. Why don't we look at Bob's computer to see what he did before he left? Well, IT says that we've wiped that computer. And so that may or may not mean something. IT may not have actually wiped the computer. Maybe they killed off the user profile or something like that. It doesn't matter. You and I need to have some way of telling somebody, well, here's kind of what might be true about that device. Now let's go see if it is actually true. And here's the way I suggest people think of your computers and your cell phones or digital devices. It's all explained in this slide. This slide is great. I truly enjoy this, and in lots of seminars that I've done for attorneys, those of you that might be watching that have taken some of the hundreds of different seminars I've done have seen this slide more than once. Let me go through it with everybody just a little bit. First of all, what the heck is this? Well, written really in small letters down here, this is a mock-up. It appears to be a mock-up that was made at a trade show or perhaps a museum. It is a mock-up. It is built by the Rand Corporation, and it was built in the year 2000, it was built in the year 1954. It was built in 1954. And in 1954, when the men and women were building this, and you were asking them, what are you building? They would tell you, we, the men and women of Rand Corporation in 1954, are building a home computer as it will appear in the year 2004. This is your home computer in the year 2004, built as a mock-up in the year 1954. This is what people thought would be possible in the year 2004. A, once they could shrink things down to this size, this thing's only a small room, this is what they thought they might be able to get away with. Now, 1954, we're not even approaching miniaturization through transistorizations and stuff like that, but this is the computer. And let's take a look at this a little bit and see if we can decipher what the heck they've got in this alleged computer. First, we got this thing. This appears to be a very important computer. It's got little wheels on it, and it's got some wonderful little handles, etc. on it. And this looks exactly like a nuclear power plant control rod drive system to move the control rods up and down in a nuclear power plant. And this looks like some kind of actuator. And these things here, I have no idea what the heck they're supposedly telling us about the operation of a computer, etc. But this image was put out in a magazine in 1954 as a projection of what the future would look like. And by the way, for those of you that do your homework, it really is the image of a nuclear power system. But that's okay. In 1954, this is what people thought of what a computer was like. And when we take a look at this, what is true about this image that is also true today? First of all, computers and this image are very complicated, powerful, and dangerous. This doesn't invite you to show up, buy this for your kid and let him play with. This appears to be a printer. This appears maybe to be some kind of monitor. But the real question we've got for our purposes here today to teach something is, what's this guy doing here? Who is this guy who looks just like, or relatively like, Dwight D. Eisenhower? And if you don't know who that is, then I'm a lot older than what I thought. Dwight, what is this person doing here? Well, here's what I want you to take away from this slide. And if you keep this in mind, a lot of the digital world will make a lot more sense to you. This person's job is to keep you, the human, away from that computer. This person's job is to ask you, as the human approaches the computer, is to step forward and say, what do you want? And whatever you want, I'll go get for you. You don't need to do anything. You just sit here, I'll get it for you. Back in the day, computers had only command prompts. You'd open up a terminal, a little blinking light, blink, 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 and you had to type stuff. Command prompts. You had to type, and the language had to be exactly correct. If you typed a sentence and you wanted the computer to do something, you hit a space in the wrong place, didn't do anything. If you didn't do the right kind of bracket, computer didn't do anything, or worse, it did something you didn't want it to do. And one of the revolutions that was true about Bill Gates and about the use of the computer today, one of the revolutions that you and I have lived through is the interface between the human and the computer, making it possible for a human that knows nothing about machine language, or a human that knows nothing about code, to be able to use a computer by using language. Well, this is a lot like the interface. An interface, much like the Windows operating system, is basically an interface between you and the manner in which the computer actually operates at the machine level. The interface makes life easy for you and tells you what it is to do. So I'm going to tell you that in every digital device that we're talking about, or that you're going to think about going forward, there are three interface old guys. And I use the term old guys, and I all know that in today's society I want to be sensitive to everybody, but I'm old. So I'm using this as my fellow old guys. There are three of us inside every one of your computers, cell phones, etc. One of us, one old guy, they're taking care of the environment. They're taking care of the temperature. They're a little bit like the person that makes sure that the building is working properly. The lights are on, air conditioning is working correctly, the doors are all open, or some doors are closed. Doors that need to be closed and secure are secure, etc. So there's an old guy running kind of the system of the computer. There's another old guy running the file system, and that old guy is trying to take care of, where do I store stuff so that I can find it again? How do I store it so I can find it again? So the first old guy, he's running what we're loosely going to call the operating system. He's taking care of making sure the computer is running properly. He's like the Windows operating system. I got all kinds of information here. And for those of you that use Windows 8, 7, 10, 11, you can go and talk to the old guy from time to time by going into systems and telling him, I'd rather configure you to do this, or do it this way, or do that this way, change the way this looks, change the ways that look. You're kind of talking to the old guy and setting him up, but they're running the environment. The file system old guy, that's a pretty important guy. That person is in charge with storing stuff in places so we can find it again. And you can talk to him too a little bit. When you go to save something, for example, in a window environment, and a little pop-up comes up and says, where do you want to save this? You're telling the old guy, okay, I want to save it in this folder, and then what do you want to name it? Well, I want to name it this. And then what file type do you want to save it as? Well, I'd like to save it as a PDF or a PNG or whatever. Absolutely excellent. So, so now you're talking to the old guy as well a little. So that old guy handles, okay, here's how I'll file everything. And then finally, there's kind of an old guy for every or for most application that you've got. Again, you fire up an application called Word, and you want to go in and change things in the way that you want it to launch with a blank page. You want a certain template to change. Well, you're talking to the old guy that's in charge of Word. The file system guy's not doing Word, the operating systems guy's not doing Word, and the Word guy's not doing the operating system. They each kind of run in their own lane. And the other thing I want you to know about old guys is they're built for speed. Even though we're old, we're built for speed. We do everything we can to make your experience on a computer as fast as possible. In fact, built for speed you need to keep that in mind, because if you ever have a question, is something deleted or not? Is something true or not? Speed should be your first thought. Because if I can do something on a computer or a cell phone faster than by actually deleting something, I'm going to choose the faster method, because speed trumps everything. That's kind of the rules we're talking about. So we got 3 old guys per device at least. And we've got speed is our big reason, and we're going to keep this thing in mind. And let's take a look at how that paradigm, how to think about these things. Why do I care that there are 3 old guys? Well, each one of those old guys, in addition to speed, they act the following way for our purpose. 1, they don't have a great memory, so they write down everything they're doing. They write down, and I always tell people, think of it as writing yourself Post-it notes on everything you're doing. I got up today, 9:02, Post-it note. Okay, I'm done with that Post-it note, throw it on the ground. Check the front door, it was locked, throw it on the ground. Started the dishwasher, 9:05, throw it on the ground. We write ourselves Post-it notes. Each old guy, the operating system, the file system, and the application old guys are writing themselves Post-it notes, and they're using those Post-it notes for 2 primary reasons. 1, they're using those Post-it notes to accomplish their job, and so operating systems like store the Post-it notes on a stack, and they make sure they're getting everything correctly, and if anything gets mixed up, the operating system guy, that's how things happen now. And then when something crashed, way back in the day and you had the blue screen of death, it was because the Post-it notes got out of order or got messed up somehow, and the operating guy couldn't figure out what was going on, so he just crashed. And then you had to restart up everything. The operating guy wake up, come back to life, start writing Post-it notes again. Today, the operating guys, the file guys, and the application guys are a lot more sophisticated. But for our purposes, they still write Post-it notes. They write down what they're doing, and they write that down so they can share that information around. Hey, I'm doing this right now. I'm doing this right now. I'll be with you in a millisecond. I'll be with you in 2 milliseconds. And that concept of writing down Post-it notes, and then when you're done with the Post-it notes, don't bother to erase them. There's no reason. You don't want them, just throw them away. I.e., throw them on the ground. And we'll see what that means in a moment. Just get rid of it, the Post-it note. So, what does that mean when we apply this paradigm to a computer? And so we just do a little mini walkthrough. A real simple way is, okay, I got 3 old guys, I got a computer. Well, a computer is a little bit like a library, and as I told you before, it's got a lot of information in it, but the file system guy needs to know where the books are. The operating system guy is keeping the library open, keeping the temperatures correct, etc. The file system guy, he's actually running the library to figure out what's going on. So our file system guy, let's say, is a special librarian, and we're going to use Thor the librarian. He's our file system guy. Inside the computer, Thor is in charge of keeping the library. It means 2 things. I got to figure out where to stick a book when you tell me to save it, and I got to be able to find what I've saved. Those are the 2 big things. I can't put something someplace and then forget it. That doesn't help. And I can't be at a place where I just randomly stick things someplace and then can never find them again. So Thor needs a way to work. And the way in which Thor basically works generally is Thor not only keeps track of everything going on in the library, but Thor uses a card catalog. And actually in a computer, there's a thing called the master file allocation table, the master MFT. Thor, our librarian, handling the file system, uses a card catalog. And I've been told that's not Thor. I've been told that's Conan the Barbarian. I'm still referring to him as Thor because he's always been Thor to me. So in any event, our file system guy, whatever his name is, has to use a card catalog. And that's how the finds out where everything's at. So every document you've got, that document sits on a hard drive or inside an SSD, a solid state drive. It sits at a location. And that location is a lot like the shelves of books in a library, where the card catalog might tell us that the book that you want is on the 3rd floor, it's on the 8th row, it's on the 5th shelf, and then it's in the 6th book in. It tells us exactly where the book's at. And there are file systems, lots of file systems. We use the Dewey Decimal file system for most of the card catalogs in libraries, but there are all kinds of different file systems in the world. And so this file system tells us where every book is at. Also, when a new book comes into the system, well then the file system guy has to create a card. And indeed, when you go to create a file and it asks you, where do you want to save this file, what folder, and what do you want to name it, a card in effect is created. And that card has in it not only the name you gave the file, it has not only where the file is going to be found on the hard drive or whatever, but it also has in it other information that we call metadata. It has today's date, it has today's time. It has other information about that file. And it keeps that card, and every time you access that file or modify it, that card gets updated. Metadata gets updated. So in the master file table on a computer, in this card catalog on a digital device, is all kinds of information about the data that's in that device, and that information is being maintained by the file system guy. Pretty straightforward. So why is it, therefore, that delete doesn't mean delete? Well, this is how computers work for speed, and it's a great example so I can help you understand why it is it's important to get some idea of how the devices work as well. Delete doesn't mean delete because it takes too long. Think about this. If I told you if I told the computer, quote unquote, hit the delete button, well, file system guy wakes up and says, okay, you want me to delete this book, right? Yes, that's what I want. I want it deleted. My life depends on it being deleted. Or I want this note that I wrote. I want it deleted because I no longer wish to rob the bank. So I want it deleted. And the only thing I've got on the machine is delete. I'm hitting the delete button as many times as I can, but that's what I've got. Well, what does Thor, i.e. also known as Conan the Barbarian, what does Thor do? He's not going to run up to the 3rd floor, go to the 5th stack, 8 shelves down, 6 books in, and do anything. What he's going to do, he's going to go to the card catalog. He's going to go to the card catalog and say, here's what I'm going to do, card catalog. I'm going to change the first letter of the name of your file to a tilde, a little squiggly line. That's deletion. That's all. Why? Because now the application, the file system application librarian knows that's a deleted file. So it's not there. So we're going to pretend it just doesn't exist. Is the file still there? Absolutely. Can I still get to the file? Yes. How? I mean, my application, Thor, he doesn't know how to get to the file. He's been told, ignore it if it's got a tilde. That's where forensic work comes in. As I told you, you've got 3 guys living in your computer, an operating system, a file system, and individual applications. But suppose I put your computer to sleep, and then I use a forensic computer, and I in effect let my operating system guy, my file system guy, and my application guys go into your computer. That's really what forensics does. We in effect use operating system guys that can traverse your computer, go into it, and we find the things we want, even though your operating system, application, and file system guys, they cannot. Just like, it's no more complicated than this, just like some humans have got other functionality, characteristics, and skill sets, so too do forensic and other operating systems have different skill sets, characteristics and functionality and capabilities than do the ones that came with your device. And so we can, in effect, approach your device and say, we can do things and, quote, find stuff on a device that you can't. It's no more magical than saying that we know the limitations of the people you're working with in your device, and those limitations can be overcome, surpassed, or completely irrelevant when we use different people to examine your device. Which is why when IT personnel sometimes say, well, a matter was deleted, or somebody says, well, I know for a fact when you hit delete, it's not deleted because it went in the trash. Okay, so here, this is what happens. Now it's in the trash bin. Can you get it back from the trash bin? Sure. And in fact, in today's system, instead of a tilde, there's a dollar sign. Same kind of thought, though. It's identified as in the trash. Well, suppose you empty the trash. Now, I like this. Suppose you empty the trash. Well, initially, from what we've been talking about now, we've opened our eyes, we know that initially our device lied to us when it said delete. We hit delete, and we used to think back in the day that meant delete. Now at least we know you hit delete, it doesn't get deleted, it goes to trash. Okay, so a bit of a white lie. Okay, it went to trash. But now, how about I go to the trash bin and I empty the recycle or empty the trash bin? I empty it. And I get a little pop-up box. Warning, danger. If you empty this, all your data is going to be lost. He said, yes, that's exactly what I want. I want the data lost. Hit the button. Is the data lost? Well, one, we should always be thinking, well, why should I think the device is telling me the truth now? Remember, the device communicates with me through these old guys for the functionality the device is built for. It's not communicating with me to be a witness. It's communicating with me to be a computer. It's communicating with me to say, hey, when you hit the trash button, you will no longer have access to all this data. And I'll make that in English for you. You know, all the data will be gone. It'll be deleted. You won't be able to get back to it. And that's true as far as your device is concerned. Is it true as far as the reality? Is the data actually gone? Is it overwritten? Has it been overwritten? Well, there's a thing called secure delete. You can hit down, I forget what secure delete is now. In any event, you can hit down a couple of buttons and securely delete a particular file. And the trick is, well, it's supposed to overwrite that file. How would you know if that's possible, though, using just your own computer? I used to kid with people all the time. There was a piece of software called Evidence Eliminator that was sold for a long time. And I had lots and lots and lots of cases that had Evidence Eliminator on the computers. And people would buy Evidence Eliminator because if you went out and looked at the website, Evidence Eliminator would tell you, my goodness, people are getting convicted left and right for what they thought they deleted, what they thought they overwrote, but it's still there. But our software will get it. Well, for those of you that are attorneys, there's at least one case in Ohio where the mere existence of Evidence Eliminator downloaded after the fact constituted spoliation in a matter, because the good news about Evidence Eliminator always was you didn't have to ask why you bought it. It was Evidence Eliminator. The purpose came with the title. In any event, for our purposes, therefore, deletion isn't really deletion, and all these things are going on because rather than take the time to find the book and rip it up or do something with it, normal deletion simply modifies the master file table because that can be done really, really quickly. And there's no reason to go find the whole book when I don't need to. So in this instance now, this is an example of why it is deletion doesn't mean delete. It doesn't really get rid of the book. What it does do is it moves it in a certain way, maybe lying to you even about the trash, and how it is that we can find that information by simply putting the three old guys to sleep and examining your computer or your cell phone with something else, and the data might still be there. So as a final part of this particular podcast, I want to show you a little bit more now about metadata, because this is kind of a common mistake that people make. A lot of attorneys I see make this too. I get a lot of times where attorneys will say, I don't understand something. I'm looking at a spreadsheet or I'm looking at a device. And on the information I've got is a file that says it was created on, say it was created on February the 14th, 2020. Valentine's Day 20. It was created, but it was modified in December of 2019. How could it have been modified 2 months before it was created? And they're looking at different metadata fields and they're confused. And you're going to see how that can be true here in just a second. What we're going to take a look at is we're going to take a look at Jpeg and Png. We're going to take a look at those two files and we're going to examine what metadata of those two files look like. Now, example, we go back to the fact, you take a picture of something, you take a picture or you take a screen capture and you get metadata. And in fact, you can see some of the metadata, not all of it sometimes, but some of it, by going to a file, right-clicking the file, going down to Properties, opening the Properties box and looking to see. Now, JPEGs and PNGs contain a lot of metadata. JPEG files especially got a lot of stuff, and if you do that with a file, open it up, look at the properties, pull it out, or sometimes look at the file the same way but inside an application that created the file, you'll see what kind of camera took the picture, you'll see the interesting points about how far away from the target was the camera, all kinds of neat stuff. And on that point, metadata, meaning information about the file itself, the metadata itself might be vitally, vitally, vitally important. Easy case. Now, almost 15 years ago, easy case. Attorney absolutely upset and very concerned that a client that had an order against them, like a civil protection order, told you can't come within 100 feet of somebody, let's say. Well, here the person produces a picture, and the picture makes it appear that the client is very, very close to the person, meaning it's either a telescopic lens or they were very, very close. And the testimony is, I was shocked to see my ex or this other person that I'm frightened of, for which I have a civil protection order, I was shocked to see they were 20 feet away from me. And I told them right then, I'm going to take you back to court and I'm going to demand you get punished for violating the CPO, the Civil Protection Order. And here's a copy of the picture. And the picture is given initially as a printed image. Got to go back and get me the original JPEG file. Get me the file. The file is given. You hit the property box and look, and sure enough, it's pretty straightforward. In the metadata, as I was able to explain, in the metadata, in order for some cameras to work, the distance between the camera, the focal length, the camera needs to be adjusted. The distance between the camera and the target have to be calculated to some degree, and sure enough, this metadata had information that clearly indicated that the picture, when taken, the person was several, hundreds of feet or whatever away. So the picture, the native file picture, the camera itself, the camera was the entity that said, I know how far away I was from this person when I took this picture. I know how far away I was, even though humans either didn't know or might be lying. So in terms of JPEG, we're all kind of familiar with latitude, longitude, altitude information on some of these things. There's a EXIF is a type of metadata associated with digital cameras and JPEGs, and there's all kinds of information. And you see, subject distance, 1.6 meters. So the picture was taken, let's say, 3 or 4 feet away. It was surprising in a sense, if you think about it. There's no reason to get all crazy about how you're going to prove something when the metadata tells that to you all the time. But now, either as a client, a company, or even as an attorney, you know that the device that was used, get to the device. And you also now the problem is when getting printouts of things, you're not getting to the device. You're getting the content of an image on the piece of paper. Well, that's nice. And if the issue was, is this really a picture of the X? Well, maybe that is the issue. Is this really the real person? No, that's not them. Well, maybe you don't need the metadata for that. But when the issue goes beyond the content that you've been given and gets into what is the environment in which that picture was taken, well, then it becomes real important to get into the metadata, and it becomes important to understand how does this information get transferred amongst devices. So we've got lots of different metadata fields that we can see here, etc. And in some of these fields, we can see not only the type of camera that was used, we can see the exposure time, and all kinds of neat stuff here. In fact, these are always fun to go through and look at. Number one, it's important to note, you can buy software many times that allow you to modify these fields. That's important. You can buy software that allow you to modify these fields. So whenever we read these fields, and wherever we get information off of these fields, we also want to make certain that these fields haven't been corrupted by the addition of information that may not be true. And so you'd want to know ultimately, is there on this computer not only the camera information, etc., that got transferred from the camera to the computer, but is there also on this computer some type of software that allows people to change these fields? And then there are also some artifacts that we can look at that we can try to determine where any of these artifacts changed, as we in effect try to validate the data that's in these fields, because that's part of the process of converting them into witnesses. But let's just walk through a scenario. And in this scenario, we're just going to walk through something that's going to take us all the way back to the how did I get these modification dates that occur before creation dates. JPEG files are created when you use your camera and you take a picture. Not all the metadata fields are populated in a JPEG file, but lots of them are. Pretty straightforward. The camera generates a lot of information, and then the camera saves that information along with the photograph, along with the picture, sometimes on an SD card, and then that SD card is taken and put into a computer and downloaded, and now you've got the picture on your computer and you can see the metadata fields, etc. PNG files are somewhat different. PNG files are generally made when you squeeze both sides of a phone and you create a screen capture. Now, creating a screen capture like on an iPhone, you press the side buttons, you create the screen capture, and now you've got the picture on the phone, and you can send it to people and do things with it at that time. And you can go read all you like about how to create these pictures, what might the metadata be associated with a PNG file. But let's think about this. Once you create a PNG file on your iPhone, let's say, so you've squeezed both sides of the phone, you create it, the phone automatically names the PNG file as img_number.png. The phone gives the file a name. The phone also gives the file, the phone's file system, gives the phone a creation date. It gives the PNG file the creation date and time of the time on which the PNG file was created on the iPhone that made it, or created on the Android that made it. Created, okay? So, and the time is the time in the time zone in which the phone was located when the PNG file was created. So there's three things to think about here. So the metadata associated with the PNG is created by the phone. It includes a name given to the phone in a sequential number that looks like img underscore this. But it includes a creation time and date, and the timepiece is set to the time zone in which the phone was in. Oh, I like this. So now, you send that PNG file to somebody else. Once the PNG screenshot is created, it can be sent. The recipient phone receives the PNG screenshot as an attachment to an SMS or to a message file. The PNG file on the recipient's phone is saved in the attachments subfolder of the messaging system, and this is important, the recipient's phone renames the PNG file in the same format, img_png, using sequential numbers generated by the recipient's phone. So now the recipient phone goes, okay, I just got this file as an attachment. This PNG file will now be known as img_0025 blank 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 blank, because that's the next number on the recipient's phone, and this is important. And the recipient phone gives the PNG file a creation date and last access date different from the original one. The new file on the recipient phone has a creation date set to the date and time zone that the recipient phone was in when it received the PNG file. So now I've got, oh, this is great. I got the same picture, but now I've got on the recipient phone, it came in and has a creation date of one date and one time set to the recipient phone's date, time, and time zone, and the sender phone date, time. They can be different. Now that can be wonderfully important, absolutely important to know that a file was sent and the difference in times, etc. But it also explains why it is that even on a computer, that you can have a creation date on a computer that occurs after a modification date. And the reason is because when that occurs, the rule to remember is this: the creation date I'm looking at is the system file, is the file guy telling you, here's the date this was created on me. So if you've got a creation date of February the 14th, 2020, that's the date it was created on that computer. Here's the date it was sent to me. Here's the date I filed it in my library. This is the date. If you open that file, maybe it was like a Valentine's Day card or something, it might have another date inside it. Internal metadata. It might have another date inside that says, Happy Valentine's Day from 2019 or something, who knows. But the date, the metadata, the creation date of the file is the creation date that it was sent on your system. Therefore, it also includes, the file system also brings over, send over the file, send over the metadata. I'm changing the metadata creation date to be the creation date on my system. But by the way, on the computer card, I'm going to keep the modification information as sent to me. So if the file was modified in 2019, but sent to me in 2020, here's what I'm going to have. I'm going to have a master file table. I'm going to have a file that has in it creation date, today, modified, maybe a year before today. Nothing, not even big. What does that mean from an investigative process? It's one of the fastest ways to know, am I looking at the original file from the original machine, or am I looking at something else? Am I looking at a copy? Am I looking at it was sent to me? It's dead bang certain that you can't modify something before it's created. That's true. But if I'm looking at files where the creation date comes after the modification date, then I'm not looking at the machine on which those files were created. I'm looking at a different machine. And that's really important and should be done early in these types of investigations. And some of this stuff you can do yourselves. This is not necessarily something you always have to hire somebody to do. So this podcast, in just a brief way, we just started to go down the rabbit hole that's called forensics. Other podcasts, we talk about the 50,000 foot level, try to open your eyes to the wonderful world of digital devices. This podcast, we try to give you an idea of why these things make such great witnesses. What is metadata? What does the metadata tell us? How do we think about these devices, the three old guys, file system, application system, and operating system, those three old guys, why are they great witnesses? Because one of those three guys may indeed, in order to work, to operate, may have written information in terms of metadata or artifacts that indeed will help us prove something. Ain't got nothing to do with the content of the file necessarily. It's got everything to do with the operation of the systems, the operation of the device. And next podcast we'll go into is give you an idea of why networks, when devices talk to one another and they start to build information at the network level, why that information is also vitally important as a witness.